Good morning, everyone. Thanks for attending this Azure DR webinar. My name is Gary Jensen, a Principal Consultant at Silversands, and I'm with my colleague Michael Coutanche, a Senior Azure Consultant.
Good morning, everyone.
In today's session, we'll be covering the importance of disaster recovery and how Microsoft Cloud Solutions can help. Mike will provide a brief overview and demo of the technology, and then I'll finish up with some licensing considerations before I summarise the session. We aim to finish by 11:20, but we'll be around at the end for Q&A, so please submit any questions via the Q&A interface. The webinar will be recorded, so you can share it with colleagues afterwards. As a business, you are delivering services to customers and end users, and I'm sure that everyone puts a great deal of importance on maintaining these services and preventing downtime. If you do suffer an outage though, there could be a number of impacts, including financial and sales penalties, brand damage, lawsuits and even job losses. Clearly, all outcomes are ideally avoided. So to protect your data and service provision, there are three core capabilities you typically need to consider. Backup to protect your data to allow restores in the event of individual hardware failure, deletion or corruption of files, and to protect against ransomware and similar attacks. In addition to this, you may have high availability to protect your primary and critical services against downtime caused by individual or short-term hardware or server failures. This might include e-commerce systems, public websites, ERP, and financial systems. Neither of these solutions, however, will protect you in the event of a massive infrastructure outage or complete data center failure. At this point, you will need to have some element of disaster recovery solution and processes to recover to a working business state. So, although we know that the impact of an outage can be very damaging, implementing disaster recovery has historically been challenging with the additional requirements and costs of hardware, secondary data centers and/or third-party services. Testing has been painful, with IT resources sent to a DR location for a week with hundreds of tapes, only a partial recovery being completed and/or services not being tested to their full operational capability because it's simply too difficult. In a DR invocation, it may take a long time to get services up and running, and it's quite likely that not every production service is available. In some cases, organizations may end up not having any DR capabilities and may rely on best endeavors approach in the event that this happens. So Microsoft have a number of services and capabilities that can support disaster recovery, including the infrastructure as a service elements of the Azure Cloud Platform, together with the Azure Site Recovery Service. These capabilities and services can help by reducing the challenges of cost and complexity while improving compliance. So from a cost point of view, with Azure, there's no need to purchase additional hardware or sites. You simply pay for what you use when you need it. From a complexity point of view, there's no long procurement cycles or infrastructure bills. You simply turn on the services you need, so you'll be able to get going faster than before. Testing is simplified, and because Azure delivers business continuity of the service, there is no need to patch, manage or upgrade the software. From a compliance point of view, Azure supports many certifications, which ensures that you can build whichever services and applications you need, enables more applications to be available in a DR situation, and allows you to comply with governance, audit or insurance requirements. Okay, I'm now going to hand over to Mike, who's going to give you a brief overview and demo of site recovery itself.
Okay, thank you, Gary. So I'm just going to take a few minutes giving people a feel for site recovery, essentially, and what Microsoft solution offers in terms of benefit and functionality. So many of you are going to be no doubt familiar with Azure and the numerous features that it currently offers. But for those that might not be, this table on the screen currently gives an idea of the PaaS and IaaS services that currently fall within the Microsoft Cloud as of today. As you know, today's webinar is focusing purely on site recovery, which is Microsoft's DR cloud offering, but in reality, site recovery utilizes and integrates many of the Azure compute, networking, and storage components when failing over to the cloud. So what does site recovery actually do? Well, site recovery allows you to protect machines running in your on-prem virtual environment, whether that be Hyper-V to Azure, running on single Hyper-V servers, which I'll demonstrate shortly, running in a clustered Hyper-V environment, or in fact deployed and managed by Virtual Machine Manager. In a similar way, it allows us to protect machines running in a VMware environment, again running on standalone hosts or managed by vCenter. And it also protects physical machines that can be replicated to site recovery and stood up in Azure if required. The replication replicates the machines which will sit dormant in the recovery vault, where essentially you pay purely for cloud storage and a nominal cost per instance. Then when DR is evoked, the machines are then hydrated as full IaaS VMs, and the charges for these machines are then applied accordingly. So as well as on-prem machines, it's also possible to protect machines running in other clouds such as AWS, or even between Azure regions now. So in addition to protecting VMs to Azure, site recovery can also be used to leverage IT investment and manage DR between two on-prem data centers using site recovery, whether that be site recovery between VMM physical data center to another secondary VMM data center, or a physical or VMware environment to, again, a secondary VMware data center. It's possible to link in other technologies such as SAM replication, which will enable us to transfer data between two sites. Site recovery also supports not just Windows guest OS, but also various Linux distributions, so whether that be Red Hat Linux or Ubuntu. Essentially anything that is supported by the on-premise hypervisor is supported to be protected and failed over to Azure accordingly. So let's just have a quick view of some of the capabilities that site recovery offer. So near synchronous replication for our protected machines. So site recovery provides replication frequencies as low as 30 seconds for Hyper-V and continuous replications for VMware or physical machines. Site recovery offers application consistency, where machines can be replicated, keeping application consistent snapshots for either single or multi-tier applications. Site recovery also integrates with in-app replication. For example, you can use site recovery to protect SQL Server backend of corporate workloads, including native support for SQL Server Always On to manage the failover of availability groups, AD domain services to replicate data for AD between domain controllers. Site recovery also supports simple network management. So it simplifies appliance network management, whether it be reserving IP address, configuring load balancers, integrating sort of global load balancers such as Azure Traffic Manager, much for an effective network switchover. No impact DR drills with test failover for site recovery. You can easily run test failovers to support disaster recovery drills without affecting ongoing replication or applications on-prem. Site recovery brings with it orchestrated recovery plans for disaster recovery, so you can customize and sequence failover and recovery of multi-tier applications or multiple VMs with a recovery plan, which you can then group machines within the plan and add scripted or manual actions. And finally, site recovery allows you to create on-demand dev test copies in Azure. It's also possible to therefore take copies on demand of data being protected by Azure and stand these up for test or development environments identical to that of which applications are on-prem. So I'm now going to step into a quick demo just to show you how easy it is to DR to Azure. So before looking at the Azure portal, if we take a look at the Hyper-V host that I'm looking to protect, on my standalone Hyper-V host, I'm running two demo servers. Demo server 1 is currently being protected by site recovery, and we can see down the bottom that the replication server target is actually Microsoft Azure. And if I right click on the machine and view the replication history, or the replication health, sorry, we can see that the replication health is normal, when the last replication was taken, and how many successful cycles have been in the last 24 hours. If we then select Demo Server 2, we can obviously see at the bottom that this server is not currently protected by site recovery. So if we jump to the portal, we can look to do that. So from within the Azure portal, if I browse on the left-hand side to Recovery Services vaults, then from the list of vaults that are presented to me, I pick the demo vault. The first thing that I'm presented with is an overview of any machines that are replicated currently or protected by site recovery, or in fact anything that's protected by Azure Backup. So to add protection for our virtual machine, it's as simple as clicking on Replicate. We can then select the source location, choose the target configuration, and for the purpose of this demo I'm going to leave that as standard. And then from the list, pick Demo Servo 2, which is the one we're looking to protect. We need to tell site recovery the version of OS that it's currently running and the virtual disks that we want to replicate as part of that virtual machine. And then the final step is just literally to choose the replication policy that outlines the frequency of copies and any application snapshot frequency. Click OK and enable replication. And in the background, site recovery will go and create a Delta copy of that virtual machine into the cloud, which we can then later on fail over if we need to. So if we look at replicated items, we can see that Demo Servo 2 is beginning to synchronize an initial copy. But actually, if we take Demo Servo 01 at the top, which is currently in a protected state, we can right-click, select Test Failover, and then from the pop-up menu we can choose the recovery point that we want to fail over to, and also the network location that we want that test VM to actually power up in, and then click on OK. Behind the scenes, that's now hydrating that virtual machine into Azure IaaS, where we can then run tests against the machine without any kind of disruption to the on-premise virtual machine itself. And typically that's going to take 10 to 15 minutes for a single machine, but obviously the more complex the recovery plan, excuse me, or the larger number of virtual machines, the longer that period of time will take, depending on that platform. Okay, that at a very base level is as simple as that is. I'm going to pass you back to Gary.
Thanks, Mike. That looks very straightforward. Okay, so before I summarise what we've talked about today, I just wanted to cover off some important licensing considerations. So the primary requirement is to have software assurance on your application licenses. This enables the right to run the applications in the Azure data center, and with this comes the disaster recovery right, which is what effectively allows you to have DR protection, testing and failover. This is only available with software assurance, and it's only valid when you're using site recovery. So with ASR, you can do DR testing, you can fail over to DR, and you can fail back within 90 days. If you don't have ASR, then technically you're not allowed to do any DR testing. You can fail over to DR, but then you would have to maintain that DR for the 90-day period. This may be a problem because your on-prem disaster may have been resolved within a few days and you may want to fail back in order to get back all your services up and running. It's worth noting that this is for Microsoft licensing. Other third-party software may have its own rules. So from a licensing point of view, ASR is licensed per protected node. So each node that is replicated into Azure for recovery purposes would require a license, and you only pay for storage costs during this BAU running state. The only additional costs then are when you invoke a DR, the all recovered machines then will incur standard Azure charges. So we know that DR protection is a requirement, but it can be hard, complex, costly and difficult to invoke. And Azure Site Recovery is a simple and effective solution to provide disaster recovery protection for Hyper-V, VMware, or physical Windows and Linux machines. Software assurance and ASR are the key enabling requirements, with full machine running costs only applicable during a DR invocation. So we think this is a great solution for DR protection, and we hope you do too. So thanks for attending our session today. Before we come to the Q&A, I'd just like to thank you for attending, and please complete the survey that will be emailed to you afterwards, and which will allow you to obtain your free half-day consultancy engagement. Otherwise, if you'd like to know more, then please feel free to contact us through the website. Okay, so I'm going to take any questions that have come up. Okay, so Mike, can ASR do anything else?
So yeah, I mean, the ASR typically is a disaster recovery technology. However, it can be used in a number of other scenarios. The main scenario we use it for would be for migration purposes. Obviously, if you're looking to migrate applications from on-prem to the cloud, then typically we would look to either re-architect those applications or redeploy them fresh. But for applications that have bespoke configuration, sometimes we can use Azure Site Recovery to obviously replicate that machine or multiple machines to the cloud and obviously fail over and leave them in the cloud.
Okay, and do we need any special infrastructure on premises?
We don't need any additional infrastructure on-prem. Depending on the scenario, for Hyper-V we definitely don't. For VMware or physical machines, then we need to deploy a management server on-prem, so that can be a virtual machine. We can deploy it to Azure. Obviously it depends whether there is an on-premise connection to Azure in the first place. But other than that, no physical requirements really.
And do we need any special network connectivity to Azure?
Not for site recovery to work. It will replicate virtual machines or physical machines over the public internet to Azure. At the point that you want to fail over or DR to Azure, then if you have on-prem users trying to connect to those cloud services, then obviously a VPN or something like a managed connection like ExpressRoute in the Microsoft kind of case, then yes, you would need that kind of connectivity to the Azure subscription.
Okay, and does it support any application?
It's agnostic of the application that's running on the virtual machine. It's more a case of whether the application is supported in Azure longer term and how that actually functions. But Site Recovery will take any virtual machine that is supported by the hypervisor that you're cloning from and replicate that as is to the cloud. So.
Okay, just another question coming through. So how quickly can an application be running in a failover situation?
So it depends really on how complex the application is. A single machine can be failed over to Azure in about 10 to 15 minutes. Multiple tiered applications or full data center failovers can obviously take a number of hours depending on the complexity of the recovery plan that's in place. Obviously, majority of those steps are going to be automated though, apart from maybe a handful of manual steps that have been added in for sort of checkpoints. But it really depends on the application that we're trying to move really.
Okay, and I think possibly the final question, how would end users connect to a server running in Azure after a DR invocation?
So that kind of goes back to the question earlier on whether there's actually any need for sort of a network connectivity to Azure. So if you're actually using kind of Azure as your DR location, the machine will be spun up, it will be infrastructure as a service, it will essentially be a virtual machine running in the cloud. So we'll need to either have a VPN in place or a sort of managed connection from on-prem to the cloud to allow the on-prem users to connect to that. We can kind of give them public endpoints and people can RDP to them from remote locations if they want. Obviously there's a slight security risk with that, and if it's part of an sort of other set of applications, then perhaps they can't connect. But it's a case of looking at that workspace really, or work set that we failed over, and what requirements they actually need. But essentially, as long as we have a VPN in place, when that machine spins up in Azure, it can change an IP address, update DNS, whatever it needs to do, and the end user will connect to it in the same way as they would normally.
Okay, thanks Mike. So I think that's all the questions, unless anyone else wants to ask one. So I think we'll stay online for another 10 minutes if anyone does want to ask another question. Otherwise, again, thanks for attending, and we'll follow up with an email of the recording of the session, and we hope to see you again in the future. Thank you very much.